Is a jet engine a heat engine? Why or why not? And if we think about examples of heat engines that we already know are heat engines, we've mentioned how Sadie Carnot talked about the steam engine, and most steam engines, they have like a boiler, but then there's like a cylinder attached to it, and there's a piston in that cylinder, and the heated and high pressure steam essentially pushes that piston outward as part of the cycle in order to produce work. And if you think about a modern car engine, the modern car engine also has a cylinder and piston, but it's an internal combustion engine. So the real difference there is that with a modern car engine, the fuel is combusted inside the cylinder rather than combusting somewhere outside of it and just transferring heat into it from the outside, which is more like what a steam engine does. So in that sense, one might be tempted to think that a heat engine really should always involve some kind of cylinder, but a jet engine does not necessarily have cylinders in the same sense. However, what it does have in common with those other forms of heat engine is there is high pressure gas that expands in order to do work. What else the jet engine has in common is there is fuel that combusts and produces thermal energy at a high temperature and can be thought of as the energy source for the jet engine as a heat engine. And it also produces waste heat. There's no way to remove it. So that makes a jet engine a form of a heat engine. An interesting aspect of history, actually, is as we're exploring this, is it turns out some of the physics that is developed from these ideas actually helped develop more efficient turbofan engines, which is not exactly a jet engine, but jet engines, it turns out, are not quite as efficient, which if you want to produce or create large airplanes that carry either a lot of cargo or a lot of passengers for as little fuel used as possible, you'd like to have an efficient engine, which may not be the best thing if you're creating, say, a military grade fighter jet, right? But for, again, commercial airliners, the turbofan engine what kind of evolved from jet engines, but engineers looked at it from the point of view of this physics-based heat engine model and then said, how can we make it more efficient and not necessarily performance oriented? I digress a little bit here. Let's return to the question. The clear answer is yes. Amazingly, this is another form of a heat engine. So it's really quite amazing what number of different things. And when you look at the engineering involved in each one, it is different for all of them. And yet still is a heat engine because when you look at the energy flows involved, it fits the definition.